Okay, so let that be a binary operation on a set of real numbers defined by that. So how do we solve this question? Okay, so I'll write that. So a binary operation is on B, A and B, and it's A minus B squared subtract AB, right? That's what we have there. So we want to evaluate that. So broad-mass guides us to say that always start with what's in the brackets. So we have negative 1 start 3. So in this case our A becomes negative 1 and our B 3. So I'll substitute in. Okay. So where there is A we have negative 1. Where there is B we have 3. And it should be squared minus AB. So our A is what? Our A is still negative 1. Then our B is 3. So negative 4 in brackets. Negative 4 squared will give you 16. Minus negative 3 there. So it will become 16 plus what? Plus 3, which will give you what? To give us what? 19, right? Okay. So as for we've not answered the full question. We've just tackled what's in the brackets. Okay. So are there any questions there? Kindly mute your mic. Okay. So okay. So what you've seen now, what's in the brackets? That's where I've put the 19 now. So now you have a binary operation. Okay. Which part, sir? Have you not understood? Okay. Yes? I'm getting you. It's not actually multiplication. It's not multiplication. It's a binary operation. It can denote anything. Okay. So don't look at it as multiplication. Okay. So what is very key and very important for you to notice is when you look at this. Okay. So you have A star B, right? So if it's acting, if it's on negative 1 and 3, A is what? Corresponding to the negative 1, then B 3. So where there's A, we'll put negative 1. Okay? And that's what we did. So we had the A there, then we also had the A there. That's why we had put negative 1. Then on the parts where we had B, that's where now we put this other one. Okay. It's a binary operation because it's on two different members. Okay. So you start with a brackets. Because there's no way you can work it all out at the same time because it's a binary operation only on two things. That's why it's A and B only. Okay. So what's on the right hand side will guide you what to do. Whether you add, you subtract, it's that will guide you. Okay. Are you clear now? Okay, so we have now 19 and what? And 2. So we have 19 minus 2 squared minus, okay, so 19 minus 2 is what? 17. 19 by 2 is 20. Oh, fit what? Fit 8? Okay. So 17 squared is 169 if you know mathematics. I don't know. I hope I'm right. 169? No. 17 squared is what? So this is what? 2 what? 249? I don't know.
289. 289.
289? Wow.
Yes.
Minus fit 8. So I have 250, 251. Okay, so I have 251 as a solution to the first part. Any questions, sir? Okay, people are quiet. So if our value is 251. The second part of the question says, is the binary operation commutative on a set of real numbers? So when is it commutative? It's very important to note. What does it mean when they say commutative? So commutative means whether you start with A or B, you're supposed to have the same solution, right? So an example of multiplication is a very good example of commutativeness, where you say 2 star 4 is actually equal to 4 start star 2. This is true for what? For addition and what? Multiplication. So meaning that 2 by 4 and 4 by 2 is going to be the same, right? Even addition, it doesn't matter which one you start with. That's what it means to be commutative. Okay, so now how do we get to show it in this case? So we know our A star B has already been given. So let's come up with our B star A. So it will be, where there is A, we'll put B instead. So it will be B minus A squared minus BA. Okay. So you can consider now expanding the brackets. So B minus A in brackets is same as B squared minus 2AB plus A squared. So BA is the same as AB, so minus AB. This will reduce to B squared plus A squared minus 3AB. So what is for B star A? So how about A star B? A star B, of course, has already been given to B. A minus B in brackets squared minus AB. Let's try to expand this as well. So you have A squared minus 2AB plus b squared minus ab. So we have a squared plus b squared minus what? 3ab. So I don't know if these are the same or they're different. Anyone to comment? Okay, so if they are the same, then we can. Okay. So they are the same. So what can you say? We can therefore make a conclusion to say the binary operation is what? It's commutative on a set of what?
Commutative.
Yeah, it's commutative on a set of real numbers. Okay, because yeah, doesn't matter which one you start with, you still get the same solution. Okay. So how about when they say associative? How do you get to show it? It's also a basic, not very hard, not very. It's not hard. Okay, let's try to. Okay, so is a star associative on the set of real numbers? So how do you show that? So a binary operation is said to be associative when A star B. Mhm. Okay, let me even show it better. When A star B and C in brackets is equal to A star B in brackets star C outside there. So this is when it is said to be what? So this is when it is said to be associative, meaning that doesn't matter which one you consider to be in brackets, provided it is being acted on three different members, the solution is going to be the same. Okay. So if you're able to remember, for the first solution there, what was our answer? 251, right? Is that what we got? Forgotten. Anyone was writing down?
251.
Okay.
It was 251.
So how about if now change it? We start with okay, we will remove -1. Then you now say star 3 and 2 in brackets. So let's try it out if we're going to have the same solution. Okay. So we'll start with 3 star 2. So remember where there's A, that's where we're going to put 3 because they are corresponding. It's A star B. So you have 3 minus 2 squared minus our A is 3, our B is 2. So 3 minus 2 in brackets is 1. 1 squared is just 1. Minus what? 6. Which is -5. We've determined what's in the brackets. So we can now say you have -1 start -5. So you now have your A is -1, then your b is negative 5 squared minus your a is negative 1, your b is negative 5. So what are we going to have there? So you have negative 1 minus negative 5 is going to give you what? Positive what? Positive 4, which is going to be 16. Negative 1 by negative 5 will give you positive 5. So what you are going to have is 11. So now you ask yourself a question. Are they equal or they are not? So
They are not.
they are not the same. And we can therefore say that the binary operation is not associative on a set of real numbers. Okay. So that's it. I believe these are the many concepts that they like testing on when it comes to the binary operations. They'll ask you to evaluate, they'll ask you to determine whether it's commutative or associative on a given set. Okay. So one thing that is very important that I mentioned in the video, in case if you didn't watch it, I would advise you watch it because it will help you understand some of the basic concepts. Okay. There are some questions like basic concepts that I've not talked about in this question, but they can ask you about. Okay. They can give you a set. They say set A, for example, consists of members 1 up to 4. Then they say determine whether addition is a binary operation on the given set. Okay. Let me try to show it. What I'm saying is, they say, let A, instead of stating you real numbers or natural numbers, they can just say, set A consists of members 1, 2, 3, and 4. So they'll ask you, determine whether I said what? Addition? Determine whether addition, subtraction, multiplication, and division are binary operations on the given set. So when is it a binary operation and when is it not a binary operation? So it's a binary operation when the result is within the given set. Okay? Not so. So 1 plus 2, you have what? 3. Is it within the set?
Yes, it is.
So are we going to say it's a binary operation or not?
It is.
It is?
Yes.
Yeah, I see. Our main course is we just want to look on the negative part of it. That's the only thing that can get that is the binary operation or not.
Okay. So I think Mr. Emmanuel is the one who watched a video. Lindiwe, I guess you didn't watch a video. You should watch it. Okay, I wanted to mislead you. Okay, so it's not a matter of you saying no, 1 plus 2 is part of a set. Think of the things that are going to make it not true. So how about if I say 1 plus 4? So are you going to say it's within the sets? It's not, right? Okay. That's the way to go about it. So addition is not a binary operation of that set. Because not all the combinations are going to give you the result within the given set. How about subtraction? Is it a binary operation on that set?
This subtraction is not a binary operation because given 1 minus 2 should give him that 1.
Okay.
So that is the set.
So it's not, because we already have impossibilities. So 2 minus 4, 1 minus 2, these are not part of a set. Okay, how about multiplication? Is it a binary operation?
So multiplication is not by
It's not.
binary operation.
Okay. I think this set is giving a lot of negative solutions. Okay, let's change it a bit. How about if we reduce the set to just, we say it's only made up of 1 and 2. We'll start with addition. Is it a binary operation? Anyone to respond?
If it's addition,
I know.
then it's
So it's 1 plus 2 is
Okay, it's not. 1 plus 2 is 3. Okay.
addition. No, it's not a binary operation.
How about subtraction? How about subtraction?
on this one. I just think like
So 2 minus 1 is 1. 1
subtraction is a binary operation.
1 minus
Yeah,
2.
1 minus
Yeah, 1
It's
minus 2
not
is.
a binary operation for subtraction, since when you do 1 minus 2, it will be negative 1 part of the set.
Okay. So thank you. So 1 minus 2, it's not. So this is not. This is also not working. How about multiplication? Is it a binary operation on that set?
It's
multiplication is a binary operation.
Okay, so 1 times 2 is 2. 2 times 1 is also 2. So they are all, the results that you're getting are part of this given set. So it's a binary operation. Our division, 1 divided by 2, you have 0.5 already. Then 2 divided by 1 is 2. So 1 is not part of a set. So it's not a binary operation on that set. I think this is enough for tonight. We end here. If you still have questions, let's have the questions shared to the group. Okay, in case you've joined late, the class is recorded and I'll share the link. Thank you very much. Good night.